So let's look into the second page of this graphic design cheat sheet. It starts with implementation considerations. And there it's first really good to look into what influences what. So that if, for example, you have independent variable, always take that on the horizontal axis, and the dependent variable always on the vertical axis. Aspect ratio, so how you look into, for example, horizontal versus vertical lines is really, really important. They are also kind of making sure that you have good understanding of if you have, for example, categorical time things like baseline, week 1, week 2, week 4, week 8, week 24, that these are not equally spaced and that you take that into account. There's very often things that are screwed up because of that, because especially when you use Excel, then it just looks at this as a categorical variable and ignores the metric on the timelines. Then if you want to have, for example, show something over time, you could use bar charts for that, but sometimes it's much better to just show the ends of the bars, because that is the most important one. Can be sometimes, if you want to more emphasize the area under the curve, so something like the cumulative death, or if you want to show kind of the cumulative burden of the disease or things like that, then this area under the curve makes more sense and could be considered. Also think about whether you need to connect the lines or not. Connecting the lines makes most sense if there's actually something like an interpolation possible. If there's no interpolation possible, then connecting the lines can still be reasonable if you want to show that there's actually these belong together. So using this graphic principle. If you have log normally distributed variables, so let's say a ratio, an odds ratio, then make sure that you have the treatment effect, so to say, symmetrical around the one. So that if you get the response and the non-response or treatment A and treatment B exchanged, then this has no kind of impact on the size or the width of the confidence interval and the treatment effect. That happens if you have then the just a scale, usual kind of scale from 0 to 100 or something like this. And of course, everything that is a ratio below 1 gets squeezed in this little space between 0 and 1, and everything that is beyond 1 gets this large bars, and that kind of distracts and actually doesn't also make a lot of sense. So rather use something on a log normal, logarithmic scale, so that the 0.5, so half, has the same distance to the one like 2. When you measure data on the same scale, then also make sure that you plot them on the scale, same scale. That is usually much more helpful. There's certain kind of variations from this. So like always, first learn the rules and then learn how to break the rules. If you have largely different things that you're comparing, like for example, there were COVID-19 rates and you wanted to show kind of how is something happening in Rome versus a more rural part of Italy, then of course it doesn't make sense to, just compare these absolute numbers against each other. Then of course you need to somehow take into account the size. So that matters then. So, but have a conscious discussion about it. If you connect data, so like on a time scale, then that implies that there's some kind of measurement possible between these things. If you have some, missing data, mark that, and use maybe something like a greater outline, or if you have some kind of or a dashed line, and make sure that it's clear where you're interpolating, where you're extrapolating. It's even better if you show also the confidence intervals and say are wider there where you maybe have less measurements. In terms of, I talked already about the categorical displays that is again mentioned here as well. It's always really good to also show some kind of levels of variability. So if you have data and there's hardly any data that has no uncertainty, well, otherwise, you put a line just to 2 points and you don't have any uncertainty. But if you have real data, then you always have uncertainty. So try to include this uncertainty. There's lots of different ways that you can do it. The most common way is probably to have some confidence bands or to show some kind of fading around it. Alternative ways of showing that is, for example, showing a couple of different scenarios. So basically sampling from the model that you have created maybe 100 times, and that way people get a feeling for what is a variability there. And with good kind of overlay mechanism, you can then manage that. If you have then with the next one, the legibility and clarity, that is really important depending on how the graphs are used. So if you have a graph that is used with a speaker, then of course the speaker could, talk a lot to it. But if it needs to stand on its own, then you need to have more annotations in it. So include the units and make sure that you have kind of additional annotations there. Maybe you know about certain data points that are, outliers, why they are outliers. Maybe you have something like a specific range that you are interested in. Have these included, so people see, okay, this is the areas that we want to have the data in, and that's a danger zone. Make always sure that your font size is readable, especially if things are displayed maybe on smaller devices or are displayed in a large room and people see it from the back. Make sure it's readable. I've been in so many presentations where the most important description of the data was in an annotation that was really, really small to read. And only the people in the first rows could actually see it. So avoid that and make sure that you have everything readable. In terms of font size, of course, you can also play with it and make sure that, for example, the title has bigger font size than the access descriptions, and these, again, more higher font size than the any other kind of additional annotations like references or things like that. And of course, you can also there play with the color and boldness and using gray, for example, to put additional levels and layers into this into these font sizes. Make sure that all the annotations are easily readable. So especially if you, for example, have annotations within bars, yeah, that when you have some big bars and they're easily readable in these bars, but then you maybe also have some small bars. Make sure that you then have these labels outside of the bars, and sometimes that also means that you need to change the color of that font. It's already mentioned earlier in the cheat sheet that sans serif fonts are better than the with serifs, and there's a really nice example where you can directly see it on this cheat sheet. Make sure that you have a good contrast and that you can always clearly see the data and the data points. On the cheat sheet, there's two examples there. And one is where you have dark bars and then white numbers in the bars. And the other example is having dark bars and then dark numbers on top of these bars. I think there's pros and cons to both sides, but it needs to come through quite clearly. So that helps a lot. By the way, in this bar, you also have no y-axis, which is actually, by the way, a nice way to get rid of it. If you show the data and the data points itself, then you can actually get rid of that. You see that very often, for example, in newspapers. Bold or italics can also be used for making sure that you have some layering in the in your font, but don't overuse it. So not everything needs to be in bold and not everything needs to be in italics. Use it really for the areas where you want to emphasize it. So using it only rarely probably helps a lot. The final thing here on the legibility and clarity part is a really, really important one. And that is what happens if you have vertical bar charts in Excel and you have very long labels. Then Excel automatically puts an angle on these, so something like a 45-degree angle on these labels. And you need to kind of twist your neck to actually read them. That's really bad. If you have long labels and bar charts, organize your bars horizontally. Then you can put next to these bars very easily the treatment labels or the any other labels that you have, and have a very, very easy way to read it. And so that, for example, works with if you have adverse event data, or if you have other long labels, especially if you have even combinations of different categories, then that works very well. So at the end of the Good Graph checklist is also a really nice Good Graph cheat sheet. It's also a really nice checklist. It's ordered in a couple of different sections. The first is about clear communication. The second is about facilitating comparisons. The third is about color for emphasis and distinction. The next one is about implementation considerations. And the last one is about legibility and clarity. So you can basically use that and go through it, mark everything, whether it's maybe some of these are not applicable, but you can just quickly go through them and see whether all of them are met and adjust them if not. So this is really helpful for, both if you're doing visualizations, but also if you're checking and want to improve visualizations and see whether, you meet all of these. At the end of the cheat sheet, there's also some really nice book recommendations, like, for example, from Tufte, from Cleveland, Few, and others, and also the online resources. So have a look there and see that. So credit goes to a couple of authors from Novartis. They are also mentioned there. So Alison, I'm not sure whether I pronounce that correctly, Margolski, Mark Bailey, Baldur Magnussen, Julie Jones, and Mark van der Meulebrücke. So thanks to these nice colleagues that have created this nice cheat sheet.